So, orthodontic tooth movement that refers to the intentional repositioning of the tooth using orthodontic appliances like the braces or aligners. So, orthodontic tooth movement, it is a process which involves exerting controlled forces on teeth to change their position within the jaw. So, tooth, that is the solid object moving through a solid medium, that is a bone. So we know that the teeth, they are anchored within the jawbone by the periodontal ligament, that is a fibrous tissue that connects the tooth root to the bone. So when force is applied to tooth over time, it triggers a response in the surrounding bone. So this response, it is known as remodeling. So remodeling involves process in which the bone tissue, it is resorbed on one side of the tooth and it is formed on the other side of tooth. So that will allow the tooth to move in the desired direction. So pressure and tension in the periodontal ligament, it's important in this process. So when you apply pressure on one side of tooth, the ligament, it gets compressed. So this compression signals the bone to resorb, allowing the tooth to move in that direction. While on the other side, where tension occurs due to the stretching of ligament, new bone formation take place. Now the physical tooth movement, that are the natural tooth movement. They occur. The physical tooth involvement involves the tooth eruption, migration of teeth, and changes in the position during the mastication. Tooth eruption, it is a process by which teeth they move from the developmental position within the jawbone to emerge through the gums into the oral cavity. So tooth eruption, it is a axial movement of the tooth. The tooth migration means the teeth may naturally shift or move within the mouth over time, a process that is known as migration or the drift. Third are the changes in the tooth during the mastication. Mastication is the process of chewing and grinding. So during mastication, the teeth will experience functional movement. They may slide, shift or adjust their position to ensure effective chewing and grinding of the food. Now let us discuss the theory that are related to the tooth eruption. The first is the blood pressure theory. So this theory suggests that the tissue around the developing end of the tooth root, particularly the periodontal ligament, it is highly vascular. So this vascular pressure, it is believed to cause the axial movement of the teeth. So when the external forces such as those applied through the orthodontic appliance, they act on the tooth, they causes changes in the pressure of the blood vessels within the periodontal ligament, that causes a change in the vascular pressure, and it is believed to induce the cellular response in response uh, to the surrounding tissue that leads to the bone remodeling. The other is the root growth theory. So this theory was initially proposed as an explanation for the tooth eruption, suggesting that the growth of the root in the tooth would exert a force directed toward the apex of the root. So this force, according to the theory, it would facilitate the eruption of the tooth into the proper position. However, this theory was ultimately rejected. This theory suggested that the apical growth of the root was solely responsible for the tooth eruption. However, it was observed that the teeth move through a greater distance during eruption than the actual length of their root. Another reason for the rejection, the theory was rejected as the onset of the root growth and eruption they do not coincide. The root growth typically begins before the tooth eruption, yet the actual process of tooth eruption does not coincide uh, with or solely result from the growth of the root. The third is the tooth without roots, they also erupt. So this theory was rejected. Other was the Hemlock ligament theory. The Hemlock ligament theory was given by whom? Seacher. So, according to the Seacher, he suggested the existence of fibrous tissue band. So this fibrous tissue band, it is located just beneath the root apex of the developing teeth. So this fibrous band was described as spinning from one side of the alveolar bone wall to the other, that forms a network below the developing root. So according to this theory, this network was said to contain fluid droplets and that served as an important element in the process of the tooth development. So Seacher, he proposed the presence of band of fibrous tissue below the developing tooth root apex. So this fibrous element was described as containing fluid droplets and being rich in certain components. So according to this theory, the root of the tooth develops, it exert pressure against this band. So the pressure exerted by developing root against this network of fibrous tissue, that was believed to result in occlusal directed force on the tooth. The other is the periodontal traction theory. So according to this theory, the periodontal ligament that supports the tooth within the alveolar bone socket, it contains fibroblast with contractile tissue. According to this theory, the contraction of specific groups of fiber within the periodontal ligament, particularly the oblique fibers, they are suggested for the responsible for the axial movement. The periodontal ligament, we know it's a specialized connective tissue that attaches the tooth to the surrounding alveolar bone. So this theory suggested that the fibroblast within the periodontal ligament, these fibroblasts, they contains contractile properties. So when these fibroblasts, they will contract, that will lead to shortening or the tightening of the oblique fibers within the periodontal ligament. That contraction would exert a pull force on the tooth that results in the tooth eruption, or the axial movement of the teeth. Other is the migration. Migration refers to the changes after the eruption. The teeth might exhibit slight movement or changes in their position over time. So that is known as migration. The human dentition, it tends to drift or migrate mesially toward the midline and occlusally toward the biting surface. The proximal and occlusal wear can occur due to factors like chewing, grinding, or other habits. So the teeth, they tend to shift mesially and occlusally to sustain the proper interproximal and occlusal contacts with the adjacent teeth. The third is the tooth movement during mastication. While chewing, the teeth and periodontal ligament, they exhibit intermittent heavy forces in quick cycling that may ranges from 1 to 50 kg. So depending upon the physiological response to the pressure on teeth, if the pressure it is immediate and it lasts for less than 1 second, the fluid within the periodontal ligament is essentially incompressible, causing initial resistance to the forces. So under this immediate pressure, the alveolar bone may slightly bend. There may be piezoelectric effect. That means there may be generation of electrical potentials within the bone due to the mechanical stress, contributing to the bone adaptation. When continued pressure of around 1 to 2 seconds is applied, that involves the generation of electric potential within the bone due to the mechanical stress, contributing to the periodontal ligament. It get compressed, causing tooth moves within the periodontal ligament space. And when there is prolonged pressure for 3 to 5 seconds, the excessive and prolonged pressure can result in displacement of the periodontal fluid, leading to tissue compression and immediate pain sensation. The orthodontic tooth movement. Now the classical movement of tooth, it has been explained by the pressure tension hypothesis, in which states that the periodontal ligament in the pressure side results in a bone resorption, while on the tension side it leads to bone deposition. So what are the changes that occurs on the pressure side? So periodontal on the ligament on the pressure side, it gets compressed, that so its thickness is reduced to 1/3 of the original thickness. There is increase in the vascularity that will facilitate the mobilization of cells like fibroblast and osteoclast. So there is increase in the blood supply that facilitates the mobilization of cells like the fibroblast and the osteoclast. So when the forces when they are within the physiological limit, the resorption, it is seen in alveolar plate immediate adjacent to ligament. So this type of resorption, it is known as frontal resorption. What are the changes that you will see on the tension side? First of all, the periodontal ligament, it is stretched. There would be widened distance between the tooth and the alveolar process. Similarly to the pressure side, there is increase in the blood supply that leads to mobilization of fibroblast and osteoblast. Osteoblast deposit osteoid. Leading to formation of lightly calcified bone that matures into bowman bone adjacent to the lamina dura. Now what are the secondary remodeling changes? So these changes occur elsewhere in the alveolar bone to maintain its width or thickness, compensating for the tooth movement. So if tooth it is moved lingually, new bone deposition occurs on the outer side of the lingual alveolar bone plate, while the resorption it occurs on the labial side to maintain the thickness of the sporting alveolar process. Now what are the changes that you will see with the application of extreme forces? On application of the extreme forces, the root, so there will be detriment of the nutritional supply that would lead to hyalinization, as the periodontal ligament it would be compressed and there will be occlusion of the blood vessels. So that is why there would be nutritional supply deficiency that would lead to hyalinization. Undermining or rearward resorption, that means it occurs in the adjacent marrow spaces behind and above the hyalinized zone. On the tension side, the periodontal ligament will be overstretched. There would be tearing of blood vessels. Extreme force applied would cause increase in the osteoclastic activity and tooth would get loosened in the socket. Now, what do you mean by optimal orthodontic force? Remember, the Schwartz, he proposed the concept of optimal continuous force. So, optimal orthodontic force, it is one which the teeth most rapidly, in which the teeth it would move most rapidly in the desired direction with the least possible damage to tissue and with minimum patient discomfort. So Schwartz, he proposed the concept of optimal continuous force that approximate the tissue pressure to the capillary vessels and the blood vessels. So that would prevent the occlusal of capillaries within the compressed periodontal ligament. So remember, the forces that are below the optimal level, they will result in no significant changes in the periodontal ligament. Whereas the forces that would exceed optimal orthodontic force, that would cause tissue necrosis, that would hinder the frontal bone resorption. The Oppenheim, he modified the Schwartz definition. He advocated the use of the lightest force capable of inducing the tooth movement. So studies, they suggest that the optimal force, it should be equal to the capillary pulse pressure, that is 20 to 26 gram centimeter of the root surface area. So optimal force, it is equivalent to the capillary pulse pressure, that is estimated around 20 to 26 gram per square centimeter of the root surface area. So for the clinical point of view, the optimum orthodontic force should facilitate swift tooth movement. There should be minimum discomfort during the treatment, and the lag phase of the tooth movement, it is minimized. The teeth that is being moved should not exhibit marked mobility. And for the histological point of view, the features of optimal force has a characteristic, the vitality. It should help maintain the vitality of the tooth and supporting periodontal ligament. These forces should initiate maximum cellular response in the periodontal tissue. The optimum forces ideally induce the direct or the frontal bone resorption that results in the desired tooth movement. Now, what do you mean by hyalinization? It refers to the tissue degeneration that is characterized by formation of clear eosinophilic homogeneous substance. So it indicates local compression and degeneration of the periodontal ligament. Remember, this hyalinization, it's reversible. Now, during the formation of the hyalinized zone in the periodontal ligament due to extreme orthodontic forces, severe observed changes that could be seen. There can be gradual shrinking of the periodontal ligament. The cellular structure within the ligament, they become indistinct. The collagen structures, they begin to unite, forming a more or less cell-free mass. There are changes in the ground substance, the matrix in which cells and fibers of periodontal ligament are embedded. Apart from that, the blood vessels break down, leading to spillage of their content. There would be formation of osteoclasts that are responsible for the bone resorption. So the presence of hyalinized zone signifies that the ligament, it is non-functional, impeding the bone resorption. Now the elimination of the hyalinized zone, it involves the two mechanisms. One is the osteoclastic activity. The osteoclasts, they differentiate within. So these cells, they are responsible for removing the necrotic tissue. And second is the invasion of the cells and the blood vessels. So the cells and blood vessels, they will invade from the periphery of the compressed zone, penetrating into the hyalinized zone. So these invading cells would remove the unwanted fibrous tissues through the enzymatic activities and phagocytosis. Remember, greater the force is, wider will be the area of hyalinization. If the lighter forces they are used, then the hyalinized zone would be smaller. So a larger area of functional ligament it is available, and here the frontal resorption would predominate. Now let us consider the phases of the tooth movement. They can be initial phase, lag phase and post-lag phase. Initial phase, it occurs immediate after the application of force to the tooth. So here a rapid movement it is seen over a short period, which then stops. So that would represent the displacement of tooth into the periodontal ligament space and probably bending of the alveolar bone. So this movement involves the tooth entering the periodontal ligament space and bending of alveolar bone. So remember, both the light and heavy forces displace the tooth to same extent. Other is the lag phase, showing little or no tooth movement. So this one is the lag phase. There will be formation of hyalinized tissue and it extends up to 2 to 3 weeks. So the lag phase it is marked by minimal or no tooth movement. Instead, this phase involves the activation of cellular components in the surrounding area to initiate the tooth movement. So if the higher forces are applied, that results in larger area of hyalinization. So the lag phase tends to be longer, whereas the lighter forces results in a shorter lag phase. Second, the next phase is the post-lag phase. So following the lag phase, this stage involves the removal of the hyalinized tissue and subsequent tooth movement. The osteoclasts they play a role contributing to the bone resorption. So the tooth movement occurs through either the direct resorption of the bone surface facing the periodontal ligament or rearward bone resorption. Now, what are the theories of the... Now coming to the bone resorption. The bone resorption involves the removal of the bone tissue, bone due to the cellular changes at the site of pressure. The frontal resorption, it occurs due to the pressure directly applied to the bone, whereas the undermining or rearward resorption, it involves the resorption away from the direction of applied force, usually behind the root. Now what are the theories of the tooth movement? They are pressure tension theory given by Schwartz, fluid dynamic theory by Bean, and bone bending and piezoelectric theory. The pressure tension theory that was given by Schwartz, according to him, whenever a tooth it is subjected to orthodontic force, it results in area of pressure and tension. So area of pressure shows bone resorption, while the area of tension they will show bone deposition. The fluid dynamic theory it was given by Bain. According to this theory, the tooth movement occur as results of alternation in the fluid dynamics in the periodontal ligament. So the periodontal ligaments, it contains fluid, cellular elements, blood vessels and viscous ground substance. So the content of periodontal ligament, they creates a unique hydrodynamic and they act as a shock absorber, and when force is removed, the fluid will be replenished by diffusion from the capillaries. Other is the squeeze film effect. When the orthodontic force is applied, that would lead to compression of the periodontal ligament. The blood vessels that would get trapped, that would result in stenosis, and vessels above the stenosis, and there would be formation of aneurysm. So stenosis and aneurysm, blood gases they escape into the interstitial fluid that would create a local environment for the resorption. Other theory is the bone bending and piezoelectric theory. It was given by Farrar. He suggested that the bone bending or deformation contributes to the tooth movement. So certain crystalline materials, they produce an electric current when they are mechanically deformed. So this theory suggests that the bone deformation that would generate a small electric current that would, due to the displacement of electrons in the bone crystal lattice. The possible source of the electric current could be collagen, hydroxyapatite. So when force is applied, the piezoelectric signals exhibit rapid decay and generate an equivalent signal in direction opposite when the force is relieved. So this phenomenon is attributed to the movements of electrons within the crystal lattice. Both the bone minerals hydroxyapatite and collagen, they possess a piezoelectric properties. So when force is applied to tooth, the adjacent alveolar bone, it bends. The area of concavity promotes the negative charge promotes the bone deposition, while the area of convexity, the positive charge, it leads to bone resorption. So interaction of ions in the fluid with the electric field generated during the bone bending results in temperature changes and the electric current. So these currents are known as streaming potentials. The exogenic electric signals, they can modify the cellular activity and affect the cell membrane receptor permeability. Now remember, the bone resorption, it is done by the osteoclast. They are the multinucleated giant cells with the part of osteoclast, it is in the contact with the resorbing bone, it has a ruffled border, and they lie in the, remember the osteoclast, they lie in the base sheep in a depression that is known as horse-ship lacunae. So the osteoclasts, they are derived from premature inactive cells, migration from the adjacent bones, and formation of new osteoclasts from the local macrophages. So during bone resorption, you will see three processes: decalcification, degradation of matrix, and transport of soluble products to the extracellular fluid.